Okay. Bismillah. Okay, folks, welcome back. So we're doing this now. So key point number 5. All right, let's have a reader. Asadullah, please, can you read for us at the top of the question, the page?
Okay. A distance time graph represents a journey. The vertical axis represents the distance from the starting point. The horizontal axis represents the time taken. Real. Sophia drives from her house to a cinema. The distance time graph shows her journey. Sophie's trip to the cinema.
Okay. Right. So question. So if you look at the graphs, they're telling you what the axis is, a distance time graph. Okay, that's one of the most important things to remember in this particular question. The type of graph is a distance time graph. Why? Because the distance along the y-axis and time of day along the x-axis. Okay, so it says there, Sophie drives from her house to a cinema. Obviously, she's going to stay at the cinema. When you go to cinema, you don't just drive there, drive back home, unless you are what they call it, old school window shopping. You go there to have a look at all the pictures that are on them, drive back home because you don't want to spend any money. Yeah, being like a little cheapskate. Okay, no, so Sophie's not a cheapskate. She's gone to the cinema, she's parked up the car, and she stayed there for a few hours. Okay, and then she's come back home. So if you look at the graph now, make it a bit. So we know that she left home at this time. She arrived at the cinema at that time. Okay, so let's have Layla. What time did she leave the cinema, Layla, from the graph?
8:30.
Okay, so she left 8:30 when she got home.
Oh, she left the cinema at like
whatever that time is, yeah?
Past 8.
Yeah, so that she arrived. Okay, now, what does this part here, Layla, represent?
When she was at the cinema.
So that's the time spent at the cinema. So here we got a lot of interpretation and understanding. Okay, and Layla, what is this part here, representing this part here?
When she got home.
That's right. Okay, so this is the time left home. So now every single part of this graph has a meaning and has an interpretation, has information stored in it. So for question A, Layla, let's go. Come on. How far is Sophie's house from the cinema?
From the cinema, 6 kilometers.
Excellent. So we start from home is obviously 0 kilometers. She arrives at the cinema here, which is 6 kilometers away. Done. Read part B. Yeah. Read question B for me, please, Layla. Go.
What time did Sophie arrive at the cinema?
Okay, which we already interpreted that. We put an arrow for it. So go on then. Give me the time. Let's drop a line straight down.
5:30.
So that's going to be 5. That's going to be 5:30. So
Yeah,
we need
so
to work out a scale. So it'll be 5:45.
Yeah, quarter to
Because it's halfway between 5:30 and 6 o'clock. So we can say here 5:45 p.m. Is that right?
Yeah.
Okay, lovely. Keep going.
How long does she take to drive to the cinema?
How long does she take to drive to cinema? So how long to drive to cinema? We're going to start over here and we're going to stop over here. So 5:45 is our stopping point.
So 30 minutes.
So what time did she leave home?
She left home at 5:15.
At 5:15.
And then she got there at 5:45, so half an hour.
Half an hour, fantastic. So it took her half an hour to drive to the cinema, or 30 minutes.
Yeah.
Okay, next question. How long is she at the cinema? Which part of the graph is that then?
It's the line where she's like at the top, where she's at the cinema.
It's the flat line. Why is it flat and why isn't it angle? What does the flat part tell us?
Because she's staying still, like she's
not staying still. She means she hasn't moved in terms of her car. She's not physically staying still herself. Personally, she's moving around the cinema, but she's staying still in terms of like her car journey stopped.
Hello.
Car's in the car park, the car's not going anywhere, but the time's clicking on. Okay, so go on then.
Yeah.
So how long is she at the cinema?
She's at the cinema from 5:45 to
Yeah, to what time?
8:15.
Correct. So 5:45 to 8:15. So 5:45 to 6:45 is 1 hour, to 7:45 is 2 hours, and to 8:15 is going to be 2.5 hours.
Yeah.
Are we happy with that?
Yeah.
Okay, next.
What was her speed on the way to the cinema?
How do you work that out?
Use the distance divided by speed. The triangle.
So when we say speed,
It's kilometers.
what is the speed?
Distance divided by time.
Distance and time, yeah.
Distance divided by time. So the distance is going to be the height of a divided by the base. So we're going to look at our triangle here. Okay, I'm going to highlight the triangle in a different color now. So look at this triangle here. We need to look at the height and the base of the triangle. So the height will be the distance. So what is the distance, Layla?
6 kilometers.
And what's the base?
The time, so it would be from the half an hour.
5:15 to 5:45, which is half an hour, isn't it?
Yeah, half an hour.
Now here comes the interesting bit here now. The height is 6, and the time is a half. Now, okay, stop there. Okay, everybody, I don't want you to say a single word now. 6 divided by a half. Listen carefully to me. This is going to be a little challenge for everybody. I want everybody to send me the answer to that calculation by text, by the group chat, and only send the message to me so nobody else can see it. And I want to see what your answers are going to be. This is going to be fun. Okay, everybody, please text me your answers to 6 divided by a half. Go for it. Okay, I got an answer from Layla. Oh, stop. Layla's giving me an answer. Alhamdulillah. Eliza.
Hi.
Alia. Abdullah. Okay, so far we have 3 people with the correct answer and 2 people with the what do you call it, expected answer. Okay, has everybody given me an answer?
No, I didn't.
You could change your answer now. That's cheating, Salia. Okay, right. I think everybody's giving me an answer. Well, let me go through it now. Let's pick somebody who's got it. Okay, let me have a look. Let's see if Eliza's answer on there. Where's my mouse? Eliza. Oh, okay. Yeah, we're gonna pick Eliza. Eliza and Saleh, they were the ones who got the expected answer. Everybody else got the answer right, mashallah. Okay, so Eliza, come on. Tell us how you got your answer. Go.
I 6 divided by 2.
So if you have 6 divide, oops, what happened there? What was your answer, by the way? Your answer was?
3.
3. 3 is wrong. Okay, now, so let me give you an opportunity to reflect on that and tell me why you think that's wrong. So 6 divided by a half. Now, when you do division question, Eliza, what do we do with the divide?
You do the opposite.
And then you turn the second fraction upside
down, and then you do 6 times 2, which is 12.
So when you divide by a half, you don't get half the answer, you get double the answer. So the answer, actually, the correct answer is?
12.
12. That's a common mistake in the exam, done thousands and probably millions of times by students. 6 divided by a half. Remember, you're not working out half of something. That would be correct. Half of 6 is 3. But this calculation is 6 divided by a half. So the divider has to be turned upside down and turned into multiply. And so you add the effect of dividing by a half is basically doubling. And the way, the analogy, the example I give my students is this: you have 6 cakes Somebody's coming to your house for a party. Your mom says to you, cut them into halves, share the cakes into halves. How many pieces would you have, Eliza?
12.
Well done, girl. Are we learning from our mistakes, Eliza?
Yeah.
Making mistakes is good in maths. Learning from them is even better. Okay, making mistakes is everybody's welcome. That's part of learning. Yeah. So if any, the more mistakes you make, the more you learn. Okay, lovely. So the next question now. Let's get back to, I think Layla was doing the question with us. Okay, Layla, question F, please. I'll switch your audio back on.
Yeah. Work out the gradient for her drive to the cinema. What do you notice?
Now it says work out the gradient. I think we've already worked out the gradient because we worked out the speed on the way to the cinema. Yeah, because if she's doing 6 kilometers and she's getting half an hour, she's doing 12 kilometers an hour. If you say work out the gradient for the drive to the cinema, what do you notice? Okay, so give me a sentence.
I don't know, to be honest.
Okay, I'll give you a clue.
The speed is.
The gradient for her drive is equal to the speed.
Oh.
So the gradient for her drive to the cinema. So the cinema, not cinepio, was her speed. So gradient is equivalent to speed in a distance time graph. Okay, folks, are we happy with that? Everybody? Now look at that question. That's the kind of question you'll find in an exam paper. So they're using straight line information, you're interpreting parts, you're working out differences, you are understanding that the flat part is the car's not moving. So this is the kind of question we can expect in an examination paper. And the next one actually is an exam question paper, and I love this question because I've taught this question many times. I've seen this very popular type of question. This is from a March 2013 paper, question number 3 from a higher second paper. Okay, so let's have Eliza, please. Can you lead us on this question, please? Oh, everything okay, Eliza? What's happening there? Okay, Eliza, are you there?
Yes. Hello.
Okay, we had a little bit of a microphone meltdown there. Something crazy happened in your back. Okay, no problem. Okay, Eliza, we got 5 minutes left. Let me just think. I don't know whether we'll have enough time to do all this question. I'm trying to find something small. Oh, that's the same question again. That's good. Okay, Eliza, we'll have to come to that question later. I don't think we've got enough time to do that question to give it full justice. Let's grab another question which looks like a bit smaller question. So Eliza, it's your lucky day. You got saved by the bell, I say. Saved by the bell. Okay, Eliza, read question number 3 first, please.
This graph shows the conversion from euros to Canadian dollars. How many dollars do you get from $10? 10
euro.
10 euros.
Okay.
How many?
Yeah, so yeah, let's stop there. That's it. Now let's do the first one. So what do we do for that question? How do we work it out from the graph?
You've got to find $10.
10 euro.
Euros, and then see where it lines up.
On the graph, yeah.
So it would be.
If you try to enlarge that, but let's have a look. If you can maybe. So that's 10, 11, 12, 13. Oh yeah, it's 14. Absolutely, because 2 little squares down. So work out your scale. So how many dollars you get for 10 euros then? You get how many dollars?
14.
Okay, next. Read the next one.
So for how many euros do you get for 1 Canadian dollar?
Where'd they go? Sally, you putting marks on there?
No.
Okay, somebody's touching the screen. Hang on a second. Disabled participants attention. Okay, you can't do no more. Somebody touched the iPad and put a mark on my board. Yeah. Okay, how many euros do you get for? Why have they got that funny thing there? $1. What is it?
Cent.
No, it can't be cents. It's got to be. I don't know. That's some kind of printing or something. But basically for $1. So where's that $1?
Would it be just above the 0 on Canadian dollars?
Okay, so just above the 0. Now remember, you got to look at the scale now. So you got $5, and that's got 10 little squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if 10, so you got $5. Here's 10 little squares. So if you want to work out $1, how do you get to $1? How many squares is it?
2.
That's right.
10 euros.
So if you want to work for $1, so you got to go by 2 squares, which is here, and go across and come down. Okay, now if you look over here, the same scale on the bottom, you got 10 little squares for €5, but that's on 1 square now. So that would be half a euro. Yeah, it's only 1 square. So that one should give you half a euro. Okay, good. Next. Question C, read it for me, please.
Work out the gradient of the graph.
Okay, work out the gradient of the graph. All right. Now, tell me what you learned from your other lessons about how you work out, what's the best way to work out the gradient of the graph. Off you go.
Would you do
Give me 2 points on the line where you want me to draw the triangle. You choose for me.
you could do it what in between the 15, in between the 10 and the 15 on the euros, and then go up. Well, you can mark there.
Okay, now let's pull this graph over here. Here's the graph. So where should you choose the first point for the triangle? Where should you put the triangle? Here, the origin. Remember I told you got to find out the exact points where your line crosses, exact points of the graph. That's 1 point. If you go along, it doesn't meet another point until it gets to
Right at the top.
right to the top. Right at the top, it actually goes through a corner. It goes through an exact value. Same here as well. So now we need to make a triangle that size. So what is the height of the triangle?
8.
Are you sure? No?
Oh, 7.
Okay, I think you're counting the squares. Look at the scale on the left-hand side. 0, 5, 10, 15, and then half of a 5. So what is the size of this?
17.5.
Yeah, look here. I don't know how I think you're counting these squares, these big squares here. You're not supposed to be counting. They're supposed to be counting along here, the scale.
Or, okay, yeah.
Yeah, so don't count those. Count on this side. Okay, good. And what's the base?
The base would be
How many euros?
10.
Are you sure? Because my blue.
Okay, so it'd be 13.
Come on, is it halfway between 10 and 15? It's not 13. Yeah, halfway between 10 and 15. Exactly. So bang on the halfway. What is that going to be?
12.5.
12.5 is here, isn't it? Okay, so it says work out the gradient. So the gradient equals what? What's the formula for the gradient? How do you work out the gradient of a straight line graph?
You would
I'll give you a clue. I'll label something for you. It's no good if you can't remember the basic, Kaka. You got to work out the gradient of any line is the height divided by the
base.
base. That's basic. Or we've done right at the beginning of our topic, and we've done it again. Whenever you do the gradient, it's the height divided by the base. So you need to learn that. Okay? So what is the height?
17.5.
And the base is?
12.5.
Okay, everybody get your calculators out, please, and work that out. Calculator out 17.5 divided by 12.5 equals 'Okay, what does the gradient tell you? Anybody? In the context of the question, anybody? Eliza, what do you think?
The gradient tells you the
what. This is the important part of your mathematical understanding of this, the way it's worked out. Look at the bottom. As we go to €5, we get more Canadian dollars. So it's giving you what?
Is it the difference?
The gradient gives us conversion value. The gradient gives us the conversion value. The conversion value from euros to dollars. So basically what it's telling you is this, that €1, you put the euro in the front over here, €1, pardon me, €1, the conversion is telling us what the conversion is. So as you go along the bottom, for every number on the bottom, the top number is higher. So if you go to 10 along the euros, you get 14 on the Canadian dollars. So that 1.4 is your multiplier. It's like your scale factor in other, one way of thinking about. But here it's actually the conversion factor is giving us how we convert from euros to dollars, and that's what it means. So that's what I'll explain to you in the exam. Okay, folks, we've come to the end of the lesson. Now, I don't want to give you any homework on this part yet, because I want to spend much more time going through this part with you in the lesson. I think this part is very important to kind of bring us towards the end of the topic before we move on to something else. And there's quite a few questions that we haven't done yet. But inshallah, we can also watch this in our video, and we can inshallah finish this up video for next week. So I'm just going to stop the